Okay, welcome back to video 3. Okay, it says evaluate the following limits. So we are going to be working on these limits. So right here, the limit here is as it approaches infinity. So that tells me that it is going to be about in behavior. This is an in behavior as we approach positive infinity. So I have a degree on top is 2, so this is a degree 2. Down here is a degree 1. Also degree 2. Wrote 2, said 1. So since the degree on top is the same as the degree on bottom, we need the leading coefficient over the leading coefficient. So the leading coefficient is 3 over 1. So the limit as x approaches infinity of this function is 3. Okay, as we approach negative infinity, so the degree on top is 0, degree 0, a degree 1 on bottom. If the degree on bottom is degree on bottom is bigger, that means there is a horizontal asymptote at y equals 0. So as we approach the end on either direction, negative infinity or positive infinity, it should be equal to 0, which is the horizontal asymptote. This one, again, standard form. So on top I have a degree. This is also as it approaches infinity, so it's in behavior. So degree on top of is 5, degree on bottom is 5. So we want leading coefficient over leading coefficient, which is going to be 2 over 5. So that should be 2/5. Okay, over here. Again, this is as x approaches infinity, so this is going to be in behavior. I have a degree 2 on top. I have 2 factors. On bottom, this is also a degree 2. It's in standard form. So then we need the leading coefficients again. So to get it from the factors, you can FOIL the whole thing, or instead what we're going to do is we're just going to multiply the leading leading term of each of these, and that'll be 2x squared. So the leading coefficient on top is 2. The leading coefficient on bottom is 4. And so that is going to be 1/2. So on here, the degree, so as the limit of this function as t approaches negative infinity, once again, in behavior since we're going to infinity. This is degree 3 on top, a degree 2 on bottom. So when that's the case, if the degree on top is larger, then the limit does not exist. They are going towards infinity or positive infinity. It's going to be one of those two. Actually, the limit would exist in this case, wouldn't it? Sorry, thinking about a different section in calculus. So this one should be, let me think here. This one should be going to positive infinity. Odd on top, so it should be going to positive infinity. Here we go. Next up is actually just to verify that real quick, because I'm not 100% confident. Let me get out my calculator and we can check it. Actually, what we can do is just check some number. Let's see here. So this is 5 squared over 2. So this was, I'll get a calculator. So let's check it real quick. Oh, that is in polar form. Switch back to functions. Let's type in this real quick to see what it does. 2x to the third minus 3x over 5. Oh, this goes to negative infinity. I misread that. X squared minus 4x, graph it. So as it goes to negative infinity, not positive infinity, it's going to be going towards negative infinity. So this should be a negative infinity. There we go. Okay, last one, as we go to negative infinity, in behavior again, degree on top is 3, degree on bottom is also 3. So we want leading coefficient over leading coefficient. So this will be 1 over 2. So let's see here. More of the use the rational function to answer these questions. Domain, limit notation with in behavior. So we switch to in behavior here. So first thing we do is we factor. What two numbers, so this is a quadratic, what two numbers multiply to be negative 24 but add to be negative 2, so that'll be x minus 6 times x plus 4 all over, we got a common factor here of 2x squared times x plus 5. Looks like we have no holes, but we have excluded values at 0 and negative 5. So negative 5 and 0. So let's see here. Our domain is going to be negative infinity to negative 5 union negative 5 to 0 union 0 to infinity. Our y-intercept is when x is 0. So when x is 0, we would end up getting negative 6. So 0 minus 6 is negative 6. 0 plus 4 is 4. This is 0 on bottom. So 0 times 0 is going to be 0. So it's going to be undefined. So there are no y-intercepts. Because it's excluded value. That would also do the same thing. Okay, so then the limit as we approach negative infinity, so this is asking about a horizontal asymptote. Does there a horizontal asymptote? So we have a degree on top is 2, degree on bottom is 3. So that means there is a horizontal asymptote at y equals 0 when the degree on bottom is larger. So that means the limit as x approaches negative infinity will be 0, and as approaches positive infinity will also be 0. So as x increases without bound, the f of x approaches 0. As x decreases without bound, the f of x, the function, approaches 0. Putting e's and zeros. Okay. And finally, multiple choice down here. Which of the following is true for the input values of large numbers? So the polynomial in the numerator dominates the polynomial in the denominator. So this is so by dominates it means it's bigger. So this is asking about the in behavior. And since the degree on top is smaller, it's not that. The numerator is not bigger. The numerator is not bigger. The denominator is bigger. So there is no horizontal asymptote. So this one's not right, this one's not right, and this one is not right because there is a horizontal asymptote at 0. So the polynomial of the denominator is bigger, indicating there's an asymptote of 0. So it should be D. Neither polynomial of the rational function dominates the other. So that's if they're even. Okay. Good deal. So, next one, 17. So we got already factored. This bottom one is not factored, so we'll get 4x plus 5 times x minus 2 all over difference of squares, x minus 3 times x plus 3. Let's see here. The domain of this function is all real numbers except for excluded values. So we go from, our excluded values are going to be x can't equal -3 or +3. So we should go -infinity to -3, union -3 to +3, union 3 to +infinity. The y-intercept is, so we're going to plug in 0. If you plug in 0, you get 4 times 0 plus 5 is 5. 0 minus 2 is a -2, all over -3 times 3. And so you get 20 -40 over, that's a -9. So the y-intercept should be 40 over 9. The limit as we approach -infinity, well, the degree on top is 2. Degree on bottom is 2 as well. So that means it should be leading coefficient over leading coefficient, which is 4 over 1. So it should be 4 there and 4 here. As x increases without bound, g of x approaches 0. Not approaches 0, approaches 4. As it decreases without bound, the function approaches 4 as well. And then finally, multiple choice. Which of the following is true for the input values of large magnitude? So this time they are even, right? They're the same, both degree 2, and it looks like these are all the same as over here. So neither polynomial dominates the other. So it should be asymptote of y equals 4 down there at the bottom. Okay, well, I'll see you guys in the next video.